Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 11 container with most water. In this problem, we're told that we're given an integer array called height, which contains n number of elements, and these n number of elements are all vertical lines drawn such that two endpoints of the ith line are I0 and I to the height of I. So what we're told in this problem is that we need to find two lines that together with the x-axis form a container such that the container contains the most water. So together with the x-axis, we need to find a container which contains the most amount of water. So in this problem, the result here is 49, because we can see that we have a container here which has an area of 49, and that's the maximum amount of water our container can hold. So just by looking at this problem, we can tell straight away that this is an array problem, specifically a two-pointer array problem, because we have 2 pointers. So what we need to do is we need to store the area in a variable, and we need to shift our pointers. And every time we shift our pointers, we're going to check, is the pointer we're shifting less than the right pointer? Is a left pointer less than the right pointer, or is the right pointer less than the left pointer? And so we're going to shift the pointer which is the smallest, because we want to get the largest amount of the largest vertical lines, the largest edges of our container, basically. So let's actually hop straight into the code, and it'll make a bit more sense once we do this. So we want to first set our pointers. So our left pointer is going to be equal to 0, right pointer is going to be equal to the length of the height minus 1. And we're going to say while our pointers do not cross over, so while the left pointer is less than the right pointer, we want to create a result as well. The result is going to be initially to 0. And we want to get our area. So our area is going to be equal to the right minus L, so the left axis, or the x-axis, sorry, times by the minimum, so times by the minimum of height L and height R. Because if we choose, let's say we choose height L, and that's the smallest line, well, the water is going to spill over. So we want to get the minimum edge in our container. So let me put this in bracket as well. That's our area, and we're going to set our result equal to the max of our result and area. And what do we do now? Well, now we need to shift our pointers. So when do we shift our pointer? Well, we shift the pointer which is the smallest, the smallest, so the edge which is the smallest. So let's say height L is less than height R. Well, in this case, we will increment height L. If height R is less than height L, then we're going to increment, or we're going to decrement the R pointer, so the right pointer, and then we're just going to return result. So let's run our code. Let's check our solution works, and it does. We pass all 65 test cases. So in terms of time complexity, guys, what's the time complexity going to look like? Well, it's just a singular pass, so it's going to be an O of n time complexity. And although we do have some auxiliary variables, we're not using any extra space, so it's going to be an O of 1 space complexity. So I hope you guys enjoyed this video, and I'll catch you in the next one.